Hello everybody. Just want to make a quick little video here of a couple pieces of ore. These come from the exact same area, probably within 20 feet of each other. Same mine, same vein system. You'll notice here though, why I always say you gotta know what's in your ore. Both of these contain good amounts of quartz, a lot of iron staining in both. You can see that. This little ring here, well, there's a reason for that. I don't know if you can really see it or not, but there are some sparkle points on this, and it's not quartz, it's sparkling, and it's really kind of hard to see by the camera. Anyway, there you go, chunky piece. Well, somebody who shall remain nameless took this rock and several others like it from this area and put them in hydrogen peroxide. With hydrogen peroxide, even the stuff you can buy at Walmart, it does oxidize the ore. That means basically there's a lot of sulfur, which is this yellow line here. You can't really see it's washing out in the lights, because this little spot right here is actually like, in real life, it's about like a color of an orange actually. It looks yellow here, so it's off a little bit. If you take hydrogen peroxide, it'll oxidize the sulfides and other things that are available inside the ore. A lot of times the ore has in it gold that's locked up. Yeah, this is a very good case of it here. I'm going to switch hands here because I'm not going to play with this. You'll see I'm playing with this in the glove in a minute. Now, under hydrogen peroxide, and again, you can see the ring around the ore from the sulfides. You can tell what the layer was. Now, all that in there is all arsenopyrite. All that shine. You can get in there a little close. You can kind of see, it'll focus, the scallops in there where some of that arsenic and the pyrites have dissolved out. That's because the hydrogen peroxide took it and dissolved partial of it. Same exact ore. This one had no more indication of surface arsenopyrite than this one does. There's some pieces that we found from this area, dang it, focus critter, that do have more indications of arsenopyrite and other sulfides. There is some chalcopyrite we've seen in a couple pieces, and some very limited iron pyrite. I haven't seen much of it at all in these. Thing is, though, that if you just crush these and pan them, you're going to miss who knows how much they work. I haven't had these assayed yet. Problem is that if you do crush it and pan it, you shouldn't have too much problem with the arsenic in this. However, if you oxidize it, like say if you crushed it, it got wet set for a couple days, maybe a week, 2 weeks, you start having problems with this being under biological oxidation. There is bacteria, about 4 of them if I know right, that will break down that arsenic, put it in solution. When you do it with hydrogen peroxide, you end up with arsenic in solution, which will absorb through your hands. Hence why I'm playing with this one with gloves on. Not fun stuff to play with. It will kill you. It'll put you in the bed for at least a few days, and then you'll be wishing you maybe were dead. But anyway, knowing what's in your ore is important. Just because it looks like this doesn't mean it's not like this. So for as a lode miner, you need to know what's in there. You need to know how to process this, because I think the highest I've ever seen mentioned in literature for arsenopyrite, something like 59 grams per ton, something like that, is what it can hold. It was something extremely high. It was 59 ounces. It was something outrageous. 59 grams isn't that much. Probably 59 ounces. What you can get out of a ton of general arsenopyrite ore. And obviously this one's heavy with arsenopyrite. So this one will require chemical breakdowns, crushing, panning, froth flotation, followed by oxidation, followed by chlorination, and then precipitation out for smelting. Sounds complicated. It really isn't, and this is kind of the first part of a video series I'm going to put together that shows us doing all of that. Probably won't get to the froth flotation for a while because I have to redesign those cells. They're fairly easy to do though. But that's what deadly ore looks like, but also what rich ore could look like. And we'll be having some ore coming from another area here we discovered yesterday. Had some really good looking sulfide ore, and we found the vein it's coming out of I haven't measured it yet online using Google Earth or whatever to see how the points are, but fantastic looking sulfide. We found a piece probably almost the size of a soccer ball, just full of this arsenopyrite that hadn't been leached out, that the old miners left behind. They got a whole tailings pile of it, plus the vein still runs. I say conservatively 500 feet. We have no idea what depth it goes to. The old miners um, in their initial exploration only cut a pit about 25 foot wide, maybe 30 foot wide, about 20 foot deep, and the vein is still intact. Didn't terminate that we can see from the surface. So we've got that going next week. But for now, that's what arsenopyrite and what possibly high grade refractory ore looks like. Refractory being stuff that needs to be processed. So there you go.